Okay, guys, can you see that? Question number 1, in the end of topic question, I write the given, the radius of Mars. So we have given here R. So this is the radius. So R equals 3.4 multiply 10 power 6 meter. But here, this is R capital. It is the same R small because you said the maintenance. The acceleration of free fall at the surface. So it's here, the acceleration. So this is G. G, it is 3, okay, 3.7 meter per second squared. The gravitational constant G equals 6.67 multiply 10 power negative 11. Use this information to estimate the mean density. We need rho. Rho is the mass per unit volume. We know that. Rho, the density, equals the mass per unit volume. Now we talk about the mass, which is capital mass here. The volume of sphere is 4/3 by r cubed. Now we calculate first of all the mass. How can we calculate the mass? We have the formula G equals G capital M capital over R squared. Rearrange this formula to write M as a subject. Then M equals G R squared divided by G capital. Then we can calculate M. So M equals G, it is the gravitational field strength on the surface, which is 3.7. R, it's given in meter. This is R, so it bracket 3.4 multiply 10 power 6 all squared. Divided by G, this is G, which is 6.67 multiply 10 power negative 11. By using the calculator, the answer will be 6.41 multiplied by 10 to the power 23 kilogram. We need to calculate the density. So the density denoted by rho equals the mass per unit volume. The volume is 4/3 by r cubed. The mass we calculated before, which is 6.41 multiply 10 power 23 over 4/3 multiply by open bracket r cubed. R is 3.4 multiplied by 10 to the power 6 all cubed. When you use the calculator, so the answer is 3.9 multiplied by 10 to the power 3. The unit is kilogram per meter cubed. Okay, 3.9 times 10 power 3 kilogram per meter cube. That is question number 1 in the end of topic questions. Next question is the question number 4. Question number 4 is that the figure illustrates apparatus used to find the value for gravitational constant G. Now let us see the givens here. In such an experiment, one lead sphere, so now we need to write the given. here. So here we have what here? The first mass, 1. So this is M1. So M1, the mass of the first ball or sphere, 6.5 multiply 10 power negative 3 kilogram. And the mass of the other one, this is M2, equals 0.74 kilogram. Calculate the force between them, is the gravitational force, F. When they are 72 millimeter apart, so this is R. R is the distance between them, 72 millimeter. We have to convert to meter multiplied by 10 power negative 3. So it is 72 times 10 power negative 3 to be in meter. What is the formula that we will use for part A? The formula that Newton's law of gravitation, F equals G M1 M2 over R squared. Then we substitute. This equal G capital, it is the gravitational force or gravitational constant, G, 6.67 multiply by 10 power negative 11. M1 is 6.5 multiply 10 to the power negative 3. M2 is 0.74 divided by R. R is 72 millimeter. In meter, it's 72 multiply 10 power negative 3 all squared. So using your calculator, the answer will be 6.17 multiplied by 10 to the power negative 7 Newton. Okay. Okay, guys? Yes. Okay. Just add my tool here because, okay. Yeah. Okay. Okay, guys? Yes. Any question? It's okay. Yes, Mohit. Part B, he said, comment on the size of the force. The force is very, very small compared to other forces like electric force. So this is our comment. So we say that the force is very small, is very small compared to other forces, okay, such as electric force. So this question number 4. Next question. Okay. Question number 5. Now, look at this question, please. Question number 5. We read the question and we write the given. The gravitational field strength at the surface of the moon. So we have G at the surface of the moon. It's 1.62 Newton per kilogram. The radius of the moon, so this is R capital. The radius of the moon is 1740 kilometer. So this radius must be in meter, so we convert to meter. We multiply by 10 power 3. The answer in meter is 1.74 multiply 10 to the power 6 meter. This is the radius. Yes, Mr. The question that what we don't solve Wait for end of topic, we study them. Yes, please. We have to study that questions, please. Because the final exam will come from the ministry. So we have to solve the questions from end of topic. It's very important. Yeah. Okay, here, show that the mass of the moon. Now we need to show that M capital. So this is M capital. What is the formula that we can use for part A? So the formula that we can use is G equals Gm over R squared. Rearrange the formula to write not all questions, just that question I choose related to the syllabus. Not all the questions. For example, here, I did not solve the questions in order. I said just the question number 1. Number 2 is outside. Number 3 is outside. This is number 4. Okay. Number 5. Just I select the questions that related to the syllabus. Okay. Now, rearrange the formula to write M as a subject. Yes, question. Okay, thank you. Now, rearrange this. How to rearrange this one? Multiply by R squared. So we write G R squared equals Gm. From this, we divide by capital G. So M equals G R squared over G capital. Here, on the surface, R is the same as R because we say on the surface. So this is R, it is the same as R small. Then M equals G small on the surface is 1.62. Multiply open bracket. R is 1.74 multiplied by 10 power 6 all squared. Divided by G, which is 6.67 multiply 10 power negative 11. When you calculate this value, it will be approximately 7.35 multiplied by 10 to the power 22 kilogram. So this is the first part. It said show that. So we finish this. Now, in part B, he said, the moon rotates about its axis. In the future, scientists may wish to put satellite into an orbit about the moon, such that satellite remains stationary above one point on the moon's surface. Explain why this orbit must be in equator. Because to be on the same point, I will give you a short answer and a long answer. So part B, the short answer is that, so that it, okay, is always above the same point on the equator. But why this? I explain this order. If the satellite were in an orbit inclined with respect to the moon's equator, it would appear to move relative to the surface as the moon rotates on its axis, because the moon rotates about its axis. The period of rotation of the moon about its axis is 27.4 days. Okay, so this is the time period. Now let us do this part, second part. We have here the time period. The time period is 27.4 days. We have to convert to seconds. So from day to hour, multiply by 24. From hour to minute, multiply 60. From minute to second, multiply also by 60. Then the time period is 2.37 multiplied by 10 to the power 6 seconds. This is the time period. What is omega? The angular speed. It's 2 pi over the time period. Then it's 2 pi over 2.37 times 10 power 6. So omega is here. Okay, we can calculate this value to be easier. So you can use the calculator, please. 2 pi divided by 2.37, but I use the full answer. So 27.4 multiplied by 24 multiplied by 60 multiplied by 60 equals, and then 2 pi divided by the answer. It will be 2.65 multiply 10 to the power -6 radian per second. This is omega. What is the question here? He said the period of the, calculate the radius of the orbit. Now we need what? We need r. The radius of the orbit, sorry. Yeah. So we need r small, the radius of the orbit. Now, how can we get the radius of the orbit? We know that V equals a square root of gm over r. By squaring both sides, so V squared equals the gm over r. We need m. It said find m, okay? No, we need r, sorry, we need r. Now, V squared equals, we can do cross multiplication. So V squared r equals gm. What about V? V equals omega r. And this is omega. Then V squared equals omega squared 2.65 times 10 power -6 squared multiply r squared. Now squaring the answer in the calculator. So V squared equals 7.0404 multiply 10 power -12 r squared. Replace V squared by its value. So it is 7.04 multiply 10 power -12 r. This is okay, but here r squared, because this is V squared, this is the value of V squared. Multiply another r here equals g. It is 6.67 times 10 power -11. M, it is the mass. It is given here. The mass here, it's given. The mass of the moon is 1.7. Okay, this is the show that the mass of the moon. It is 7.35 times 10 power 22. So multiply by 7.35 multiplied by 10 to the power 22. Now we simplify to get r. So, okay, 7.04 multiply 10 power -12, r squared multiplied by r is r cubed. Then this is r cubed equal. We calculate this value. So 7.04, okay, so 6.67 multiply 10 to the power -11 multiply by 7.35 multiply by 10 to the power 22 equal. So it is 4.90 multiply 10 power 12. From this, we can get r cubed. How? Divide this value here, divide this by the value beside. Okay, so we write 4.9 divided by, open bracket, 7.04 multiply by 10 to the power -12, close the bracket equal. So this is r cubed. Then r cubed equals 6.96 multiply 10 power 23. Take cubic root of the answer. So take cubic root of both sides. So we take cubic root, and also we take cubic root of this. So by using the calculator, just we write cubic root of the answer. So the answer is 8.86 multiply 10 to the power 7 meter. This is the answer of this question. This is number 5. Okay, guys? Now, there is no questions in the syllabus in the end of topic. Just that 3 questions. Again, I repeat. The questions from end of this topic related to our syllabus are, okay, question number, okay, right, yeah, mine. Question number 1. So I advise you to re-solve question number 1, question number 4, and question number 5. That's all. Now, if you have any question in the question bank, you can tell me. But we have a question here in the question bank if you have in front of you. Okay, open your question bank, please. Question number 36. It is multiple choice. Okay, question number 36, please, in the multiple choice. So this is okay. I will take a copy of that question to you. So we take a copy for this, and then we solve it together. It's a question number 36, okay, in the question bank, because we did not solve in the class. Yeah? Now, please. Now, let us resolve this question. Ready? Okay. Now, read the question with me. Okay, this is like geostationary satellite. So the time period of this one is 24 hours because it said around the Earth. The Earth has mass, so this is M capital. And the radius, this is R capital. What is the height? We need H. Follow me, please. First of all, we draw a circle. Okay, this is the Earth, for example, here. This is the Earth. Okay, and we have here a satellite. This is the satellite here. Okay. Okay, guys. Now we need to see here what about the height and the center. So this is the center of the Earth. And this is the radius of the Earth. This is R capital. And this is the height here. We need that height. Can you see? So this is the height H. What is the relation between them? The relation is that R, it is the orbit radius. It is R plus H. R is the radius of the Earth. And H is the height from the surface. We need what? The height. Then the height equals R small minus R capital. Already we have R capital. The radius of the Earth is that R capital is 6.4 multiply 10 power 6 meter. Now we need to calculate R small. Follow me step by step, please. First of all, what is the time period? The time period is 24 hours. We convert to 2 seconds. So it's a 24 multiplied by 60 multiplied by 60. Now we find this value by using the calculator. Okay, so calculate with me, please. 24 multiplied by 60 multiplied by 60 equal. So the answer is 8.64 multiplied by 10 to the power 4 seconds. Also, we can calculate the angular speed, omega. It's 2 pi over the time period. So it's 2 pi divided by 8.64 multiply 10 power 4. So by using calculator, write 2 pi divided by the answer. So it is 7.27 multiply 10 to the power negative 5 radian per second. This is omega. Okay, now what about V? V is omega R. Omega, that we don't have R. It is 7.27 multiply 10 power negative multiplier. This is V. And we have a relation. We can use it about V. We know that V equals square root of Gm over R. Gm over R. By squaring both sides, then V squared equals Gm over R. I said we need R. Then we do cross multiplication. So V squared R equals Gm. Now we continue. Yes, no? Question number. Okay, but just when we finish this one, please. Okay, yeah. So we write V squared R equals Gm. This is V. This is the value of V. Then it will be 7.27 multiply 10 power negative 5 R all square multiply R equals G 6.67 times 10 power negative 11. M is the mass of what? Is the mass of the Earth, which is given 6 times 10 power 24. So it is 6 multiply 10 power 24. Now, distribute square, so 7.27 multiply 10 power negative 5 all squared, R squared times R is R cubed, equals this value, okay? Now I write 7.27, here I write this, 6.67 multiply 10 to the power negative 11, just I calculate the right side, multiply 6, multiply 10 to the power 24. So the right side is 4.0 multiply 10 power 14. Now, R cubed equals 4.0 times 10 power 14 divided by 7.27 times 10 power negative 5 all squared. This one divided by open bracket 7.27 multiplied by 10 to the power negative 5 all square, press equal. So this is R cubed. R cubed is 7.57 multiply 10 power 22. We take cubic root of both sides. So R equals the cubic root of the answer, 7.57 times the 10 power 22. So the cubic root of this answer is 4.23 multiply 10 to the power 7 meter. Now we can calculate the height. So the height equals R small minus R capital, which is the radius of the Earth. R small, we calculated 4.23 times the 10 power 7, and R capital is the radius of the Earth, which is given 6.4 multiply 10 to the power 6. When you do the subtraction, you will get this 3.59 multiply 10 power 7 meter. Then the correct answer of this one here, 3.57, it means, okay, here, 3.6. So approximately 3.6 times 10 power 7 meter. 3.6 times 10 to the power 7. So the correct answer is B. Yes? Question, yes, question number 13. Okay. Again, so this is a long question. I can't bring this as a multiple choice. It will be extended if it will come in the semester exam. Okay. Now, one question. One of you asked me about question number 13. Okay. Let us we go to question number 13, please. Okay. Question number 13. Is it? Now I bring a question number 13 from question bank. Okay, question number 13. Okay, yeah. I take a copy of question number 13. Yes. Yes. Okay. Question number 13 here. Okay. Let us receive this question. Question number 13. Yeah. Just I take a copy of this one. Okay, Shabab. So this is question number 13. Okay. Okay. Read the question with me, please. Okay, a telescope was launched into circular orbit near to the Earth. It travels around the Earth once every 97 minutes. So this is the time period. So the given here is the time period. This is the time of one revolution. Then the given here is that the time period T equals 97 minutes. We have to convert to seconds, so it's 97 multiplied by 60. We find that the time period 97 multiplied by 60 is equal. It is 5.82 multiply 10 power 3 seconds. So this is the time. Calculate the angular speed. We need omega. What is omega? Which formula we use it? Omega equals 2 pi over the time period. The time period that we calculated, so it's 2 pi divided by the time period in second, 5.82 multiply 10 power 3. Okay? So here, it's okay. Now 2 pi divided by the answer. It is 1.08. So it is 1.08 multiply 10 to the power negative 3. The unit is radian per second. Okay, now calculate the radius of the orbit. Now, how can we calculate the radius of the orbit? Follow me, please. Okay, we know that from Newton's law of gravity, F equals G M capital M small over R squared. And also F equals M omega squared R. By equating them, so G M capital M small over R squared equals M omega squared R. We cancel M small with M small. So we cancel M small with M small. Rearrange it to get R. Now, when you rearrange, you will get R cubed because R times R squared is R cubed. So R cubed equals G M, okay, M capital over omega squared. Now we can calculate R cubed. So we can get R by taking cubic root. G is constant, 6.67 multiply 10 to the power negative 11. M is the mass of the Earth here. The mass of the Earth, it is here. What is the, okay, around here, the mass, calculate the magnitude here. What is the, because it said double, okay, near to the Earth. Now, what is the mass of the Earth? It's 5.98 multiply 10 to the power 29 divided by omega squared. Omega is 1.08 multiply 10 power negative 3 squared. By calculation, you will get here R cubed. Now I do this here, fraction, 6.67 multiply 10 to the power negative 11 multiply 5.98 multiply 10 to the power 29 divided by open bracket 1.08 multiply by 10 to the power negative 3 close the bracket square equal. So the answer is 3 and take cubic root of the answer. Cubic root of the answer. So it is 3. Okay. But here I think M here is incorrect, I think. Is it? Yes, Mr. Yes. Okay. Just I check the mass of the Earth because here, okay, Earth travel. Okay, calculate the orbit. Okay. Now follow me. Where is the mass of the Earth? I will give you because it is constant. Will be given in the exam. Here, the mass of the Earth. Okay. Okay, guys. The mass of the Earth here, it is 6 times 10 to the power 24. So this is 24, not 29. This is 24. Okay. So this is the mass of the Earth. It is constant. Okay. It will be given here. So this is 24, not 29. Sorry. This is 24. Okay. So by doing that, this is the mass of the Earth, M of the Earth. It's constant. Will be given in the formula sheet. Don't worry. 24 kilogram. By taking the cubic root, you will get the answer of R from this. So R is 6.99 multiplied by 10 to the power 6 meter. Now, here, the mass here of Hubble telescope is calculate the magnitude of the centripetal force. We use the formula of centripetal force, F equals M omega squared R. M is the mass of the telescope, which is given. It's 1.1 times the 10 power 4 multiply. Omega, we calculated before, it is 1.08 multiply 10 to the power negative 3 square. Multiply R, this is the value of R, 6.99 multiply 10 power 6. By using the calculator, you will get the answer as 8.97 multiply by 10 to the power 4 and remember the unit Newton. Okay. Okay, guys. Now look at this question. It's question number 32. It's okay. The moon has mass and its mean radius is calculate the gravitational force on a mass exactly 1 kilogram on the surface of the moon. So we need to draw this, please, to be clear here. Okay. So let us withdraw this to be clear. Okay, just 1 minute. Okay. Just 1 minute, please. I reply something. Just 1 second, please, because I received a message. Just a reply. Okay. Now I draw this figure in front of you here. So this is the surface of the moon. I draw it here. This is the moon surface. This is the moon, sorry. This is a big mass, of course. And here we have another mass on the moon surface. So this one, small one. It's okay. So this is the moon, M, capital. And this is M, small. The radius of the moon is that one here. So this is the radius. So the radius is the distance between, the two things, because it is on the surface. So now R capital is the same R small because there is no height. Which formula we use it? F, because it said gravitational force. We need F. F equals G M capital M small over R squared. Now, we can continue. So it's equal. G it is 6.67 multiply 10 power negative 11. M is the mass of the moon in kilogram, which is 7.4 times the 10 power 22 multiply M to M small is 1 kilogram. So multiply by 1 over R. R capital, it is the same as R small because it is on the surface. And the radius here is 1.7. So it's 1.74 times the 10 power 6 all squared. By using the calculator, you will get the answer as 1.6 Newton. State the value of the gravitational field strength on the surface of the moon. Now, G on the surface of the moon, or gravitational field strength, equals Gm over R squared. Actually, it is the same value because here M small is 1. Then it will be the same value that we got it here. So it's 1.6 Newton because M small is 1 kilogram. Now, calculate the weight of an object of mass on the surface. Now, we have here G on the surface of the moon equals 1.6 Newton per kilogram. Okay, Newton per kilogram. So it's 1.6 Newton per kilogram. And here we have the mass M equals 20 kilogram. What do we need? We need the weight. What is the formula of the weight? The weight equals mg. Here, m is the mass, which is 20. G on the surface of the moon, 1.6. So now we do this. The answer here, it is just the 20 multiply 1.6. Sorry, it's 20 multiply 1.6. So the answer is 32 approximately. So approximately 32 Newton. Look at question number 3, please. 2 kilogram object is tied to the end of cord and wired in horizontal circle of radius. What are the given? This is very important way to write the given here. M equals 2 kilogram and R here equals 4. So we multiply this by 4. Then we go back. Thank you, my friend. 2 pi over 3 multiply by 4. So the answer is 8 over 3 pi, or 8.38. So it's 8.38 meter per second. Now, it's V squared over R. So it's 8.38 squared divided by R divided by 4. Squaring is the answer. Divided by 4 equal. So it is 17.5. So it is 17.5 meter per second squared. Now, the pull of the object, the pull is the force. So what is the force? Is that answer is correct, guys? It's MA. Okay, here. M, if the mass it's 2 kilogram, multiply the acceleration 17.5. So this multiply by 2 equal. So it is 35.1 Newton. What happens if the car breaks? The object flies off in tangent at this speed. So we write here the object, okay, flies, okay. Okay, guys, because it is not clear here, the board. So the object flies off in a linear speed of 8.38 meter per second. Okay, yeah, this is answer. Any other question, guys? Do you have any doubt in that question? If you solved this question before, Is that correct answer? Do you have any doubt? Any comment about my answer, please? Now we go to question number 2. Okay. Muad asked me about question number 2. Is it Muad? Okay. Now, number 2, Muad, you need? Or question number 38? Okay, number 38. Let us we go to question number 38, please. Okay. Question number 38. Okay. Let us we go to question number 38. I take a copy of question number 38. Now, first of all, we write the givens. A mass of here is said the Earth may be considered to be a uniform sphere of radius with its mass. Okay, now we have given. Can you see here the mass of the Earth? It's constant that we used before, if you remember the question. So here we have the radius R capital, equals 6380 kilometer. We convert to meter, 6380 multiply 10 power 3 by using the calculator in scientific notation. 6380 multiply 10 to the power of 3 equal. So the answer is 6.38 multiply 10 to the power 6 meters. This is R capital, the radius. And the mass of the Earth, denoted by M capital, 5.98 multiply 10 power 24 kilograms. That are given. Now, let us we continue. Yeah, now. He said that a mass of 1 kilogram, so this is M small. Here we have M capital and then we have M small. It's 1.0 kilogram. Is on the equator, rotates about the axis with a period of, so this is the time period. So we have here the time period also as a given. It is 8.62 multiply 10 power 4 seconds. Calculate to 3 significant figures the gravitational force of attraction between the mass and the Earth. This mass, it is on the surface. Then we use the formula here. F equals G M capital M small over R squared. Continue, please, with me. G, it is the constant. It is constant 6.67 times the 10 power negative 11. M capital is the mass of the Earth, 5.98 multiply 10 power 24. M small is 1 kilogram divided by R here, because we talk about the surface, then R equals R. Okay, what was the R of the Earth? It was 6.38 multiply 10 power 6 meter. Then we write here over bracket 6.38 multiply 10 power 6 all squared. By using the calculator, okay, the answer will be 9.8 Newton. Let us check this answer. Fraction 6.67 multiplied by 10 to the power negative 11 multiply 5.98 multiply 10 to the power 24 over open bracket 6.38 multiply by 10 to the power of 6 close the bracket squared equal, it's 9.8 Newton. Now we need the centripetal force on. So F equals here the centripetal force on this one. This is the attraction force between both. It's okay. But now, to calculate the centripetal force, first of all, we calculate the angular speed of that mass. The angular speed, omega, it's 2 pi over t. Then it's 2 pi divided by the time period, it's 8.62 multiply 10 power 4. So the angular speed is 7.29 multiply 10 power negative 5 radian per second. We can calculate the force on that. Which formula now we use it? Here. F equals m omega squared r. R is the radius here. So, okay, he said, okay, on the period, yeah. So, m is the mass, which is 1, multiply omega. Omega is 7.29, multiply 10 power negative 5 squared, multiply r, it is the radius of the Earth, 6.38, multiply 10 power 6. The answer is 3.39 multiply 10 to the power negative 2 Newton. Just I check this answer. Okay, here, bracket, 7.29 multiply 10 to the power negative 5, close the bracket square, multiply 6.38, multiply by 10 to the power of 6. Yes, it is 3.39 times 10 power negative. The difference in magnitude of the forces. What are the forces? The gravitational force and the centripetal force. So Fg minus Fc, okay, here, equals Fg gravitational force is 9.8 minus the centripetal force that we calculated is 3.39 multiply 10 power negative 2. Then the answer here is become 9 will be 9.77 Newton.